Hi guys, good afternoon to everybody. Hi Keshav, good afternoon. So welcome to Unacademy platform and welcome to free live classes regarding the NTA UGC NET Electronic Science. So as all of you know that the electronic science subject exam is on November 5th, 2020, right? So for that purpose here the Unacademy providing the crash course on electronic science through the multiple choice questions. Of course, this crash course already started from the October 1st onwards, right? And it continues up to this month end. And if you took the subscription plan right now, you can access the previous videos also, and you can attend the live classes from the next classes onwards, fine. And while coming to the complete course for the UGC NET Electronic Science is going to start from November 10th 2020. That means after completion of our exam from November 10th onwards, the complete course is going to start. And if you want to take the subscription plan for this one, here the different subscription plans are mentioned on your screens. 1 month, 3 months, 6 months, 12 months and the 24 months. So if you are planning to take the crash course, subscription plan for the crash course, then you may take the 1 month plan. And if you are planning to write the exam, that means this crash course is for the candidates who are going to write the exam this 5th November. It will be helpful to them. And the class PDFs also you can download, which will be helpful for the quick revision for your examination purpose. And coming to the 3 months, 6 months, 12 and 24, that depends upon your wish. That means when you are planning to write the exam. So based upon that one, you may take any one of the subscription plans, right? And if you are planning to take the subscription plan, either crash course or the complete course, then use my referral code, that is Aswini K. Then you will get 10% discount on any one of these subscription plans, right? Okay guys, now we will enter into the main content of this video. That is the previous year questions, fine. So it is our first question. In the present session, okay. Hi Encom, good afternoon. What is your name, Encom? Fine. So coming to here, this question. The frequency at which the transfer function of the following RC network is 1/2 will be. That means here one circuit is given. For this circuit, if the magnitude of the gain or else the transfer function is 1/2, then what will be its frequency? Okay. So here, whenever we are using the inductors or capacitors in the circuit, then the output voltage of that circuit depends upon the value of these inductors and capacitors, and the output voltage is also depending upon the frequencies. That means if you keep on changing the input signal frequency, then you will get the different voltages, fine. So that is the difference between the resistive network and the reactive network. Hi Akshaya and Sweta Padma, good afternoon guys. So coming to the resistive network means the network which is having only the resistors. For such type of network, if you change the input voltage, then your output voltage will change. But if you keep on changing the input signal frequency without changing the input voltage, your output voltage will not change, guys. Okay, that is the case of the what we call resistive networks. But while coming to the reactive networks, means the circuits which are having the inductors and capacitors, even though if you maintain the constant input voltage, but if you keep on changing the input signal frequency, your output voltage will change, fine. So from these 2 points, what is the conclusion you have to understand, guys? What is the conclusion we have to understand means, coming to the resistive network, the output voltage depends upon the input voltage, And coming to the reactive network, the output voltage depends upon the two parameters. What are the two parameters? One is the input signal voltage and second one is the input signal frequency. Okay, so that is the difference between the resistive networks and the reactive networks. So as a part of this concept, in this question, we have to find out the transfer function. First we will find out the transfer function and then we will find out at this gain what might be the frequency. Why? Because as I told that if it is a reactive network, the gain of this circuit or else the transfer function of the circuit will changes based upon the input signal frequency also. So let's take plus minus VA of S, it is R, it is 1 by CS plus minus V naught of S, and let's take here the current I of S is flowing. Okay, so now whatever the current that is flowing through the resistor, the same current also will flow through the capacitor. Well, because here both these two nodes are the open circuited, so the current flowing through this node becomes equal to 0 ampere. So the same current will flow through the resistor and the capacitor. Fine. And now output voltage becomes is equal to voltage drop across this capacitor. So 1 by CS into I of S. Okay, we can take like this. Fine. And now while coming to the I of S, which is the current flowing through the resistor and the capacitor, so this current can be taken as I of S is equal to, just apply the KVL law, guys. You just apply the KVL law here. Okay, so if you apply the KVL law, okay, that means the current flow in the clockwise direction, then here if you observe the arrow mark is entering into the negative terminal of the input voltage, so that's why I have to write here as a minus VA of S plus I of S into R plus 1 by CS into I of S is equal to 0. Okay. Oh, hi Arnab and Nikita, good afternoon guys. And next, from this one, I of S can be taken as a VA of S divided by R plus 1 by CS. So it is the current expression and it is the output voltage expression. Let's substitute the first equation in the second equation. Then what I will get? What I am going to get is that V naught of S is equal to 1 by CS VA of S divided by R plus 1 by CS, that is equal to VA of S divided by RCS plus 1. And now the transfer function, that is H of S. The transfer function, that is H of S, can be taken as V naught of S divided by VA of S is equal to 1 divided by RCS plus 1. Okay, and he is telling about the gain, right? So gain means, let's take S as a j omega. So magnitude of j omega is equal to 1 plus j omega RC. Okay. Now, so from this point, what we can write, guys? That is equal to 1 by square root of a square plus omega square r square c square. That is equal to, in the question what they given here, this gain is given as 1 divided by 2, right? gain is given as 1 divided by 2. Fine. So let's work out about this one. Take the square on both the two sides. So if I take the square on both the two sides, then I will get, take the square and then do the cross multiplications. Then I will get 4 is equal to 1 plus omega RC whole square. Okay. And now 3 is equal to omega RC whole square. And omega RC is equal to root 3. And omega is equal to root 3 by RC. And here in the question they are asking about the frequency. So now F is equal to root 3 divided by 2 pi into RC. Okay, so that is equal to root 3 divided by 2 into 3.14 into, what is the resistor value? 100 ohms, and capacitor is the 2 microfarads. 100 into 2 into 10 power minus 6. Okay. So calculate this one, guys, and whatever the frequency you are getting, that will be your answer. So all of you understood this procedure? Fine. So find out the transfer function and then take the gain, substitute S is equal to j omega, do the cross multiplication, squarings, and then F is equal to this expression. Okay. Okay. Ramya got as 100 hertz. But in the options 100 is not there. Fine. So just take down whatever the answer you got from this expression. And anyhow, did you understand the procedure, right? So we will go to the next question. Akshaya, why we are taking the modulus? Because in the question they given the h of omega, Akshaya. Okay, so that's why we are taking the modulus to find out the magnitude. Okay. Fine. Next. Coming to the next question. So here the circuit is given and we have to find out the base current. We have to find out the base current from this question. Okay. And so if you observe the circuit, coming to the base current means, let's take the DC analysis. Take the DC analysis. So if you are taking the DC analysis means all the capacitors. If we are taking the DC analysis, all the capacitors will act like open circuit. Fine. So here open this one, open this one, and open this one. Okay. So now if you observe here, here some amount of current will flow. Let's take that is IB plus IC, right? IB plus IC amount of current is flowing, and here IC current will flow, and here IB current will flow. Correct? IC current and the IB current. Fine. So now what I am trying to do is that, and one more thing, let's take here plus minus, it is the VB, right? So let's take the VB is equal to 0.7 volts approximately. Now I am applying the loop like this from VCC to 3 kilo ohms resistor to collector to base to ground. Okay, so I'm trying to take the loop from VCC to ground in this direction. Okay, so now what I will get is that 12 volts is equal to next IB plus IC into 3 kilo ohms plus both these two resistors comes in series whenever this capacitor is open circuited, correct? So 120 plus 68 becomes is equal to 188K into IB plus VB. Fine. So it is a KVL expression, guys. And from this KVL expression, 12 minus 0.7 is equal to, and here 3K IB and 188K IB, so it becomes is equal to 201K IB plus 3K IC. Okay, so 12 minus 0.7 becomes is equal to 11.3, 201K IB plus 3K. IC can be taken as a beta into IB. Fine, beta into IB. And coming to the beta, in the question the beta is given, here the beta is given as a 140, right? So now 11.3 is equal to 201K into IB plus, so 140 into 3, here beta is 140, right? 140 into 3 means 420K into IB, correct? And now what is IB value, guys? IB is equal to 11.3 divided by 621K. It becomes is equal to how much? So calculate and then put the value here, guys. And are you getting any one of these options? So please check. Arnab, 0.0182 means, can I equate to this one, Arnab? 18.58 microamperes. Yeah, fine. So option A is the correct. Okay, guys. Yeah. So it is a way of solving such type of circuits, guys. And while coming to the next question, the unity follower circuit is. So here we know that the first option is the unity follower circuit. Unity follower means we have to get V0 by Vi is equal to 1, or else the voltage gain must becomes is equal to 1. Fine, voltage gain becomes is equal to 1. So if you take the non-inverting amplifier, the special case of the non-inverting amplifier is a unity follower. Fine. And what is the common feature of the Ramya, I made any mistake here? 188K K 188 plus 3. Okay, 188 plus 3. Oh. It is 191K, guys. Yeah. Okay. Please change this one, guys, and then calculate. Fine. Yeah, Arnab, high frequency problems we cannot expect, Arnab. So don't worry about the high frequency problems. Only the thing is asking the input impedance formulas, okay, and asking the current gain formulas with respect to the hybrid parameters. You can expect like that. So don't expect the high frequency questions in our UGC NET exam, Arnab. Fine. Ramya. So I think I did mistake in the addition, right? Okay, fine. So AV is equal to 1, guys. So it is a unity follower circuit. And if you take any one of these things, why? Because here, okay, Nikita, fine. So even though I did the mistake, got the correct answer, right? So here the virtual ground concept applies, guys. So whatever the input voltage that we are giving to the non-inverting terminal, okay, whatever the input voltage that we are giving to the non-inverting terminal, the same voltage will be maintained at the inverting terminal. So it is VA. And now it is the V0. So V0 and VA, both these two are short circuited. So V0 becomes is equal to VA. Okay, so it is a unity follower. And coming to the remaining cases, it is a VA and it is a VA here. Okay, and if we are taking some current flowing through this one, okay, like in this direction, then we will get 0 minus VA by R1 is equal to VA minus V0 divided by RF. So here there is no case of becoming V0 is equal to VA. Here also same thing, here also same thing, and here also same thing. Fine. Next. So it is a flip-flop based question. So in a JK flip-flop, we have J is equal to Q bar and K is equal to 1. So assuming the flip-flop was initially cleared and the clocked for 6 pulses, the sequence at the output will be, okay, the sequence at the output will be. So here, so if you are taking the Q of T plus 1, for the JK flip-flop, it becomes JQ bar plus K bar Q, correct? JQ bar plus K bar Q is the next state expression for the JK flip-flop. And here in this one, you can observe that the Q bar is given to the J. That means J becomes as a Q bar, okay? And here the Q bar remains same. And while coming to the K bar remains same. Okay, sorry, the K bar is given as a, K is given as a 1, right? So it becomes the 1 bar and Q. That becomes is equal to what will happen, guys? Q bar, because 1 bar becomes is equal to 0, Q bar. So that means the Q output is continuously changing or else complementing for each and every clock pulse, okay? So whenever the rising edge of the clock pulse is appeared, it changes its state. Initially it is 0, because initially clear, and from 0 to 1, 1 to 0, 0 to 1, 1 to 0. So for each and every clock pulse, it is keep on complementing, okay? So here the correct answer is the fourth option. Okay. If the question is like this, or else if the question is like this, what is the output of the circuit, guys? What is the output of the circuit we will get? Q. We will get the same answer or different answer, guys? Q. For this circuit, I will get the same answer or different answer. If both the J and K are connected to the VCC, then yeah, we will get the same answer. Fine. So we will get the same answer. And for example, if I want to collect the output from the Q bar, okay, if I want to collect the output from the Q bar, then VCC is nothing but high voltage. Okay, VCC is nothing but a high voltage. Next, if I want to get the output from the Q bar, then what might be your answer, guys? We will get 1 0 1 0 1 0. Fine. It starts with 0 1 0 1 0 1, but it starts with 1 0 1 0 1 0. Okay. Fine. Next. So while coming to the next question, a single mode fiber with radius of 4.2 micrometer with core refractive index 1.48 and the cladding refractive index is 1.475, then the cutoff wavelength is given by. So coming to the cutoff wavelength means, first of all, the optical fibers V number. Okay, V number can be taken as 2 pi A divided by lambda into n1 square minus n2 square power 1 by 2. Okay, it is a V number expression, guys. And coming to the V number at the cutoff wavelength, actually the V number is less than or equal to, okay, or else we can take as a V as a normalized frequency also, right? So V must be less than or equal to 2.405, and at the cutoff frequencies, this normalized frequency becomes is equal to exactly 2.405. Right? So 2.405 is equal to 2 pi. The radius is given as 4.2 micrometer divided by lambda c root of 1.48 whole square minus 1.475 whole square. So calculate this one, guys, and whatever the answer you are getting, that will be your cutoff wavelength. Okay. So it is the expression for finding out the cutoff wavelength with respect to the normalized frequency. Okay, guys. Fine. So what is the answer you will get from this one? Of course, it is a very big calculation. I think you will get approximately 1525. Okay, so you just calculate and whatever the answer you got, so please take that one. And okay guys, so it is a present session. Here the time is up, and we will meet in the tomorrow session from 3 to 4. in the Unacademy platform itself. That is a special class, guys, where we are going to see the August 2016 question paper continuation will takes place. Fine. Okay, guys. Thank you very much. Oh, Nikita, got the answer A? Fine. Okay. Arnab, actually, this question was, I think, 2007 or like that, 2017 or like that. So at the time, actually, I used to take the calculus to the examination center. I wrote the exam in 2012 actually. So I don't know about the right and present situation. Okay, Arnab. So right now, after starting the CBT exam for this NTA UGC NET, I hope they will give the some simple manipulating values they will give. Okay. Okay, guys. Fine. Thank you. Bye, Ramya, Nikita, and Arnab, Akshaya. Bye, guys. No, Nikita, it is 2017 or 18 paper, Nikita. It is 2018 paper. And in the Unacademy platform, right now we are continuing the 2016 paper. Okay. Encom, bye. Okay, guys, take care. Bye, guys.